Hope you are great. Today we are going to take Chapter 3, Motion in One Dimension, Section 2. So let's start. Section 2, Vectors Operations, Coordinate System in 2 dimensions. For example, motion in 1 dimension, like what? Like the motion of Gigo climbing a tree was described as motion along the y-axis. The direction of displacement of Gigo was denoted by positive or negative sign. The displacement of Gigo can now be described by arrow pointing along the y-axis. Look, when the Gigo move to the north, so I described that the displacement of Gigo was the direction of the displacement of Gigo will be in positive direction. Now, after we studied vectors, so now we use arrow to describe the direction, either arrow toward the north, which is positive, east, which is positive, north, which is negative, west, which is negative. So motion in 2 dimension. Motion in 2 dimension. We have 2 methods to describe motion in 2 dimension. First method, the coordinate system can be turned so the plane is pictured as moving along the y-axis, like this one, like figure A. When this aeroplane or this plane move 300 meters per second to the northeast, so I describe the movement of the plane by arrow, using an arrow, and the direction which is north and east, like this, which is northeast direction. This is the first method when I describe the motion of plane to the northeast direction. Second method, jet motion also can be pictured on 2-dimensional coordinate system whose axis point north and east. So we can use another method like this, y, x. So the motion of the plane 300 meters per second square per second at 45, like this. So this degree will be 45. Two different coordinate systems. A plane traveling northeast at velocity 300 meters per second can be represented either in figure A, moving along y-axis, or pointing to the northeast, or B, moving at angle 45 to the both x and y-axis, which line up with west and east and south-north respectively. Determining the resultant magnitude and direction. The magnitude and the direction of the resultant were found graphically, like when the plane moved north then to the west, so the resultant from A to B will be A plus B. This is the graphical method. This is by graphical. This method is not accurate. However, this approach is time consuming and the accuracy of the answer depends on how careful the diagram is drawn and measured. Similar methods use the Pythagorean theorem and tangent function. Use the Pythagorean theorem to find the magnitude of the resultant. the magnitude of vertical displacement, which is yx delta y, is the height of the pyramid. The magnitude of the horizontal displacement, delta x, which is equal the distance from the edge of the pyramid to the middle of the pyramid, or half the pyramid width. Note that these two vectors are perpendicular and form right triangle with the displacement d. This displacement is the resultant. Look, the Pythagorean theorem for right angle, which is equal c, this is a displacement, c power 2, or the resultant, equal a power 2 plus b power 2. So c power 2 equal a power 2 plus b power 2, or c equal root a power 2 plus b power 2. To get c, or to get x, or to get displacement, or the sum of resultant, the sum of vectors. That's it. Thanks for watching.